From the beautiful studios of Way Happy, this is Mr. Meyer and 8 2 ellipses. Now, ellipses look a lot more confusing, and there's a lot more vocab, and there's just so much more going on than a parabola. But to be honest, they're a lot easier. They're just stretched circle, so that's all you really have to worry about. And we will talk about it, but you may want to pause here and read some of this stuff just for a second to make sure you feel okay, because I'm going to kind of go through just how I graph it, and then I kind of get my understanding of ellipses from graphing. But if you need to know an ellipse, so ellipse has two very important things that we may or may not have talked about in Algebra 2. They have two foci. And so just like a parabola has a focus, these have two foci, one in each end. And then the distance to any point on the graph, if you measure the distance to the foci, you'll get a constant number. And that number will be the same all the way around the entire ellipse, right? So all the way around, the distances added together will be a constant number that never changes. So that's where those two foci are, and that's exactly how the ellipse has been made. If you ever did this in like elementary school where they hammered two nails into a board and they put a string between them, and then you pulled the pencil real taut in the string, and then you drew a shape and you made an oval, what you probably called it then, but you made that ellipse, and that's what this is now. So it's got these two foci, which are those 2 points. If you draw a line through those, that's called the focal axis. In the ellipse is stretched usually in one direction or the other, and so one way will be called the vertices and one way will be called the co-vertices. So the vertices are in the longer direction. They're on that focal axis. Um, what else could we say? The center is right between the two vertices. It's right between the two foci. And it's right between the two co-vertices. So all that stuff is there. Now, what is the standard form or the standard equation of an ellipse? Right here? Right there. There's your standard form, right? That is what ellipses look like. And the reason there's two equations is the rule is that A is greater than B. That's the rule. A is a bigger number. So you can see if the bigger number is under the X, the ellipse is stretched in the X direction. If the bigger number is under the Y, then the ellipse is stretched in the Y direction. So this is an example of if it was stretched in the Y direction, and this is an example of if it was stretched in the X direction. Now there's a lot of good stuff right there that you could memorize, and you know what? It just feels almost too confusing to me. But again, you could pause it and think about some of that stuff. Things you should know though. Ellipses are stretched in a direction. Vertex to vertex, we call that the major axis. So I'm just going to talk about this guy right here. If it's stretched in the X direction, then our vertices are in the X direction, and that distance is called the major axis, while the smaller direction is called the minor axis. So this would be what we call the minor axis, and this guy right here we would call the major axis. We also have, look on the one on the right then, the longer direction, that's called the major axis, and then the smaller one would be called the minor. And again, what it's connecting, the minor connects the co-vertices, and the vertices are connected by the major. So that's kind of important to know. That distance, maybe I can show you here too. This distance right here is A units. So whatever was under the Y in this case, we're going to square root it, and we're going to go that far up and down in the Y direction. And then what other direction is going to be B units to the co-vertices. And then the foci are going to be C units away, and they'll be in the same direction as the vertices. So that's really important to know, that A is the distance to the vertices, B is the distance to the co-vertices, and C is the distance to the foci. And you know what? We might as well give you the equation for that too, is that A squared minus B squared equals C squared. That is true for ellipses and their foci. So that's kind of like your foci equation. So A is the distance to the vertices, B is the distance to co-vertices, and C would then be the distance to the foci. All right, is that enough? Is your head ready to explode? That's a lot of memorizing, a lot of vocab, a lot of everything. And so hopefully it'll get more comfortable as we start to think about how you draw ellipses or all their different parts and stuff like that. So let me do this first example. This example says, find the equation and graph the ellipse, and graphing the ellipse. Find the equation of the ellipse with foci 0, -3, and 0, 4. So the first thing I need is a picture, just like parabolas. I'm like, I have no idea what's going on. So I'm going to draw this out. I'm going to go 0, 3, 0, 1, 2, 3. That's a focus. And 0, -3, 1, 2, 3. That's a focus. So a little thing I know already is that this ellipse is stretched in the y direction because that's the focal axis, right? That's where the vertices are. That's where the foci are. That means it's stretched that way. I know the center is right between them. So I can already tell you guys that the center is right here at 0, 0. That's our center. And what else can I tell you? The minor axis has a length of 4. So that means what does this mean? This means covertex to covertex is 4 units. So from the center, I would go 2 in each side. So if I go left 2, that's a covertex, and right 2, that's a covertex. So the ellipse looks something like that. All right. So that's what our ellipse kind of looks like. Now, what is that equation? Well, the way I write the equation in the book, we'll put the y's first. It doesn't really matter since it's adding, but so I will. I'll put x minus 0 squared over something plus y minus 0 squared over something equals 1. That's the generic form of an ellipse. You got, and the 0, 0 is the center. So whatever the center was, I would have put in. Now, if you know where the vertices and the covertices are, you'll find that distance A and B. You'll square them and you'll just put them under the right letter. Now, I do know that this distance is 2. So I will square that and get 4. And that was in the x direction. So I know 4 is under the x, right? Because if you look back at the formula, a squared, b squared, this would in fact be b squared because it's stretched in the y direction. So the bigger number is under y. Now, the bad news is I have no idea what number goes under y because of the fact I don't know where this point actually is. I have no idea. So what am I going to do? Well, I do know that the foci are a squared minus b squared equals c squared. A squared minus b squared equals c squared. We already know that a squared is 4, or you can count it. 2 squared is 4. I'm trying to figure out what, oops, sorry, that was b squared. Oh, that's bad. A squared because it was the smaller one. Minus b squared. B squared is going to be 4 equals c squared. Now, wait, I do know c squared because c is the distance to the focus. That's what, 1, 2, 3. So that's 9. So let's get that out of here and put a 9 in. And now the next thing I know, a squared is 13. So that means a 13 goes under there. And there is your equation. I guess I'd pretty it up and just have x squared. Well, here, we'll do it like the book. They like the y squared first because it's bigger. Y squared over 13 plus x squared over 4 equals 1. And that is your standard form. And then you could sketch it with Desmos, or you could sketch it with your calculator, and you should be able to see that if it really does have a minor axis of 4 and it has those foci and all that good stuff. So how would you work that backwards? You would plot the center, which is 0, 0. And then in the x direction, you'd go 2. In the y direction, you'd go root 13, which is what, a little less than root 16. So it's a little less than 4. So a little less than 4 in each direction. You'd put those points all on there and then you'd graph it. And I'm sure I'm going to do that in a minute. In fact, maybe we'll do it on the next one. So let's try it. Look at this guy here. Ellipses are supposed to be equal to 1. So as I get this equation, it looks pretty good, but I'm just going to divide everybody by 36. Boom. That's going to make it equal to 1. And so what do you have? You have x squared over 4 plus y squared over 9 equals 1. There it is. Now let's find all the parts. And the way I'm going to find all the parts is I'm going to graph it so we kind of kill 2 birds with 1 stone. Let's graph it and label everything as we go. And maybe this will be the more comfortable thing. Look at the center. Center is 0, 0. Boom. So I'll write center is 0, 0. And then in the x direction, I'm going to go 2 units. So 1, 2. And 1, 2. Uh-oh, and I only have, 20 seconds left. And in the y direction, I'm going to have to go 3. 1, 2, 3. And 1, 2, 3. So there is my ellipse. Now, the smaller one was the x direction. So those were the coverts. They are plus or minus 2, 0. The vertices were in the longer direction. They are 0, plus or minus 3. And I could find the foci in a minute, but I'm about to run out of time. So I will be back, ask you a question, and see you in a bit. All right, beautiful work. Now let's talk about maybe what will happen. Let's do these two out of order. In fact, I'm going to do the second one first. So let's graph it and then label everything, and maybe without getting cut off, this will be a little more helpful. So I'm going to start my graph over here. And what I'm going to do is I'm going to find the center, which be careful. The center is -2, +1. So I have the center at -2, +1. And then from that center, what I like to do is I like to go in the y direction 5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Those are called your vertices. So what did I do? I just took the center and I added 5 to the y. So -2, 6. And what's the other one? -2. I subtracted 5. So -4. And those are your vertices. Then in the smaller direction, you'll do the covertices. So that's in the x direction. We're going to go 4. So 1, 2, 3, 4, and 1, 2, 3, 4. Those are your covertices. So what were they? Well, in the x direction, I subtracted 4, so -6, 1, and I added 4, which would be 2, 1. And those are your covertices. And then there's your elliptical shape, right? Your ellipse is supposed to look something like, yes, I'm an artist. It looks something like that. And so there's your ellipse. And we got the center, we got the vertices. Let's just do the foci. Now, the last thing is the foci are always in the longer direction. So they're in the y direction. Their equation, and the way I remember it is I look at the denominators here and I do the opposite. See, I drew that little triangle. It's going to be 25 minus 16 equals c squared. It's a squared minus b squared equals c squared. But I have a hard time remembering that. So I just draw this little triangle and I go, okay, do the opposite of the sign in between because that's going to be true for the next shape. And so I'm like 25 minus 16, that's what, 9 is c squared. So c is 3. So we're going to go 3 units away from the center to find the foci. Now, where is that 3 units? Well, it's going to go up and down because the vertices are up and down. So I'm going to go up 1, 2, 3. There's a focus. And down 3, 1, 2, 3 is like right here. These are the foci. And so where are they? Well, I did 3 units in the y direction from the center. So that is -2, 4 and -2, -2. And there are my foci. And there's everything, right? So boom, I've nailed it all. And I think that's the better way to go. Give you an equation and let you label everything. And then hopefully you can work backwards like in the example up above. So kind of make sure that that makes sense. Why I went in the x direction 4? Why did I go in the y direction 5? Why are the foci 3 units away? And why were they in the y direction? That's just all the rules that you have to know for an ellipse. And then hopefully it won't be so scary. So now you can see I can do this example up here. Again, I'm going to graph it because I need a picture. So it says major axis has endpoints -2, -3. That's right there. And -2, 7, 1, -2, 1, 2, 3, 4, 6, 7, right there. That's the endpoints of the major axis, and then the minor is 4 units long. So I know the center's right here between here somewhere. In fact, some people will be like, oh, where the heck are we going to find it? My drawing is meh, right? So how do you find a midpoint? Well, a midpoint of those two, you just add the 2 points together and divide by 2. So I would have a -2 plus a -2 and divide it by 2, comma, a -3 plus a 7 and divide it by 2. So you really find their mean. You just add them together and divide it. They're what you guys like to call their average, right? So what is that? That's -2, comma 4 over 2, -2, 2. That's your center. So that center right there is -2, 2. And I'm feeling pretty good because I can already say, if you want to do it the right way, we'll put y first. So y minus 2 squared over something plus x plus 2 squared over something equals 1. That was because I found the center, and I know it's stretched in the y direction because they said that those are the endpoints of the major axis. So I know that that is the vertices. In fact, I know how far I went. The center was -2, 2, and it has to go all the way to -2, 7. So we went 5 units. So a 25 is going to go under the y's. Now I just got to figure out what to put in the x direction. Well, in the x direction, they tell me the major axis length 4. That means right 2 and left 2. So this ellipse looks something like this, right? And that means if I went right 2 and left 2, I went 2 squared, that is 4. I'm going to put a 4 under here and bam, done. Just graphed it for you. Just got the equation. Now, if you want the foci, we'll do, the triangle thing. 25 minus 1 is root 21. So root 21 up and down, and that will get you the foci. So that's how nice this can be. And it's a little confusing, but a little practice, hopefully in class, will get you to feel good. Now, something that you should know is that the eccentricity, well, I was almost going to go to the reflective property. Eccentricity is just another way of giving you some information. So notice right here, super important formula. The eccentricity is C over A. What does that mean, right? Well, the eccentricity is a number, it's a ratio, and C is the distance from center to foci, so to a focus, over a distance, and that distance A is the center to the ellipse. I'm sorry, center to the vertex or the vertice. So not the co-vertex, but the vertex. So it's a little ratio of their distance. And if that thing is near 0, then you're pretty much almost a circle, where if you're near 1, you're this really long, stretched out looking thing. So there you go, right? That's called eccentricity. It's just another way of giving you CNA, kind of helping you find the denominators of your fractions of your standard form. Because if you have CNA, you can find B, and then you should be able to use, if you have the center, you can make the whole equation. So that's a very important thing to know. The reflective properties of an ellipse, it's just cool because everything that comes out of one ellipse right here will go into the other ellipse. If you've ever been at the whisper chamber in San Francisco at the Exploratorium, and one person stands at one end of the room and the other person stands at the other, and they whisper, all these sound waves go out and they bounce off the ellipse, and the other person who you're whispering to actually hears you because all that concentrated sound is coming into their ear, and they're like, whoa, we're so far away, but we can hear you, bruh. And you're like, I know, crazy. It's an elliptical property, the reflective property of an ellipse. And they're like, what? So you can enjoy that. And we can talk about kidney stones one day too. That's how they blow them up. So hopefully you can pass them a little easier. But that's another day. I will see you tomorrow. Stay happy.